Hello friends, previous lecture we studied the article capacitor, ability of conductor to hold or to store the charge at low potential is called as the capacitance of the capacitor or capacitance of the conductor. Now unit of capacitance is the Faraday's unit of capacitance. C is given by formula, capacitance C is given by formula Q divided by V. In previous lecture or in applications of Gauss theorem, we study one more point, that is the electric intensity due to an infinitely long straight conductor is given by sigma upon 2 epsilon 0 K, or the medium is air, then formula becomes sigma upon 2 epsilon 0. This formula is useful to study the new article. This is the formula for electric intensity due to infinite long wire or simply a plane sheet is given by sigma by 2 epsilon 0. One more thing is necessary, that electric intensity, general formula for intensity is 1 by 4 pi epsilon 0 Q by R square, and electric potential is given by formula 1 upon 4 pi epsilon 0 Q by R. Just observe the two formulae, 1 by 4 pi epsilon 0 Q, 1 by 4 pi epsilon 0 Q, terms are constant. Then intensity becomes just simply, this is nothing but my V divided by this distance R or distance D, anything, or V by D. Therefore V becomes E into D. This one formula is required to study the today's article. Now we see what is the today's article, and today's article is very simple. Capacitance of a parallel plate capacitor. Capacitance of parallel plate capacitor without dielectric. Now here the capacitance of a parallel plate capacitor without dielectric means, what is meant by the dielectric? It is a very simple dielectric, just to take one snapshot or write down in your notebook. It is the necessary part to study this article. Dielectric means what? Dielectric means it is a medium. Now, one thing is not mentioned in the board book, that is a capacitor. There are the three types of capacitor. One is the spherical type of capacitor, means they are like this. One is the parallel plate capacitor, means the two plates are there. Symbol is also this capacitor symbol is. And one more is the cylindrical shaped capacitor. But in our syllabus, we have to study only the parallel plate capacitor, just the capacity of a spherical type capacitor and cylindrical type capacitor. These formulas are introduced in a book and also in an NCERT. Now, these are the three types of capacitor. We are studying the first type of capacitor, that is a capacitance of a parallel plate capacitor without a dielectric, means between the two plates of capacitor there is no any medium. Okay, this is my first plate and this is my second plate. Let the first plate is a positively charged, so I am drawing the positive charge here. On the second plate there is a negative charge. Therefore, the charge per unit area of the first plate, that is a sigma, means the charge per unit area, because charge is positive. Therefore, the surface density, charge density is also positive, because sigma is nothing but what? Q divided by area. Let A be the area of the each plate, and both the plates are identical. Here the charge is negative, so sigma is also negative because Q is negative. Negative charge is Q. Electric field inside the two plates is in this direction. This is the direction of electric field. Okay, electric field is shown by the parallel lines. Remember that electric field, nothing but electric intensity, is a vector type of quantity. Outside this first plate, there is a no any charge, means the electric intensity is here. Electric intensity is also here, and outside this there is a no any charge, means the value of electric intensity is obviously the value of electric intensity is a 0. Now we have to study the electric intensity outside is 0, but how it is 0? Just to simply calculate electric intensity E equals to this is nothing but a one parallel plate. The formula for electric intensity is sigma upon 2 epsilon 0. Here there is a negative charge, sigma upon 2 epsilon 0. The difference becomes a 0. So we have written the electric intensity outside the parallel plate, it will be the 0. Now we have to start. What is the net electric intensity? Net electric intensity is given by very simple formula. One electric intensity due to the first plate, it is the epsilon 0, 2 epsilon 0 plus electric intensity due to the second plate, that is the sigma upon 2 epsilon 0. I am calculating the net. So I am adding 1 plus 1. Therefore the answer becomes, it will be very simple. It becomes a 2 sigma divided by 2 epsilon 0. It becomes very simple. Sigma upon epsilon 0. This is the formula for net electric intensity E net equals to sigma upon epsilon 0. This is the formula for net electric intensity. Means the intensity which is produced inside these parallel plates, not outside the plates. Outside the plate there are no charges, therefore intensity becomes 0. But here we observe the intensity is there. How the intensity, it will be moved from first plate to second plate, or positively charged plate to negatively charged plate, and that electric intensity is how much? That is the sigma upon epsilon 0. Is it clear for everyone? Yes? Okay. Now V is given by formula, simply formula E into D. So I am using V equals to, value of E is how much? Sigma upon epsilon 0 multiplied by distance D. But what is the sigma? Sigma is nothing but charge per unit area. So substitute Q by A. Instead of sigma, we substitute Q by A. D as it is divided by epsilon 0. Now the capacitance of this parallel plate capacitor without dielectric is given by, it's a very simple formula, C equals to Q by V. So I am mentioning here Q as it is, and instead of V I am writing QD divided by A epsilon 0. This numerator goes to uppermost side, sorry, it becomes a numerator, it becomes an A epsilon 0. Q is already exists there, divided by QD. Here what happens? Q get cancelled and we are getting A epsilon 0 divided by D. So my formula becomes capacity or capacitance of a parallel plate capacitor, capacitance of a parallel plate capacitor without dielectric medium, without any medium, means there is only vacuum, its capacitance becomes C equals to A epsilon 0 upon D, and it will be clear that capacitance depends on the permittivity of the medium. Meaning of permittivity is very simple. How many that medium allows how many number of lines of forces to pass from one point to other point. It permits to travel the number of lines of forces through the medium. That is a permittivity. It is a property of the medium. Depends on the nature of medium. A is the area of that plate. D is my distance between the two plates. Now it will be clear. And one more thing is very important, the earthing, because the capacitor stores the charge at low potential. So the earthing is very necessary, which is remaining here. So capacitance of a parallel plate capacitor without dielectric is given by C equals to A epsilon 0 divided by D. Okay. How you write this point? Then I will dictate the notes or send the notes afterwards. So capacitance of a parallel plate capacitor without dielectric is formula is C equals to A epsilon 0 by D. This is very important formula. Without dielectric, capacitance of a parallel plate capacitor is A epsilon 0 divided by D. Now we study the next article, that is with dielectric. capacitance of a parallel plate capacitor with the dielectric. Now just I'm erasing this diagram and draw once again same expression, just there will be little bit changes because just we are adding the dielectric here. Plate, this is a first plate, there is a second plate. Obviously the second plate is earth, means the potential it lowers and it increases the capacitance because potential difference here increases. Now this is the first plate which is a positively charged. Therefore charge per unit area means my sigma is positive. Sigma means charge per unit area. Second plate is at lower potential, means the negative charge is given to the second plate. So charge per unit area becomes a negative. So there is a minus sigma. In between these two plates, both the plates having area A, distance between the two plates is D. Now very simple is that electric field inside it move from positive plate to negative plate, means plus sigma to minus sigma, or electric field is in this direction. Between the two plates we place another material or one slab of another material whose thickness is T. Okay, and remember that or notice that T, that is the thickness of this, is very very small as compared the distance between the two plates. The two plates are at a distance. Then slab is introduced whose thickness is very very small as compared the distance between the two plates. Okay. Now we have to study one by one and clear this point. Here the positive charge means the electric lines of forces are emitted. These lines of forces are emitted in this direction. And then what happens? That is very important. Please clear your concept here. Here from the positive plate or from the positive charge, lines of forces are emitted. These lines of forces are reaches up to this slab. Okay. At this slab what happens? These lines of forces are stops. Means what happens? These are stops? No. These are reaches here. Means electric lines of forces move from positive to negative charge. Means there is some negative charge on a one side of the plate. Okay? Or there is a negative charge. There is a negative charge on a one side of the plate or towards the positive plate. Okay? Means this is a negative charge. Or in other words, just you have to say that negative charge or opposite charge. Opposite means is the opposite. Opposite charge is induced on a one side of the slab. Means here electric intensity move in this direction. Okay. Now here the negative charge. Now the lines of forces passes through this material. Means this side becomes a positive, or simply positive charge is induced here. If the positive charge is induced here, then the electric intensity it will be moved in this way. Electric intensity move from slab to negative plate, and this region electric intensity move from plate to slab, here slab to plate. Okay, because there is a positive charge. Positive charge is induced, or opposite to this charge is induced, means there is a positive charge. Okay, this will be my direction, electric intensity. Inside this, there is also electric field, because electric lines of material or electric lines of forces passes through slab, which whose thickness is T. Therefore, through this, the electric lines of forces are moved. Its electric intensity is shown by EP, and this electric intensity I will show by another color. It will be E0. This is my E0. This is my electric intensity. Now we have to study one by one. First of all, calculate E0 means there is no any medium. In previous article we studied electric intensity. This is also parallel. Electric intensity without dielectric equals to E0 equals to sigma divided by epsilon 0. But sigma is what? Charge divided by area into epsilon 0. This is my first equation. Now we have to study the what happens about this EP. EP. It will be very simple. Electric intensity because of that EP is also very simple. Electric intensity with dielectric equals to EP, and its value is a sigma p upon epsilon 0. Why sigma p? Because here inside that there are no charges, but the electric intensity is present. Means some charges are induced, some charges are polarized. That charges are QP divided by A epsilon 0. Then how much is the net intensity? We calculate here. Net electric intensity is given by, it is very simple, that is E equals to E0 minus EP. When you substitute all the values, then we are getting, it becomes a E0 divided by K. This is what? Net electric intensity. This is my next equation. Now convert these intensities in terms of potential, because electric intensity without dielectric means at that time the potential is V0. When there is a without any dielectric, intensity is E0. Let me write the potential is also V0. At that time the potential is with dielectric, intensity is EP. So I am writing the potential is also Vp. Then what are their values that you have to write down? Here everyone know that V equals to E into D. So I am writing V0 equals to how much? Here E0 multiplied by the distance. Distance is how much? This distance is not given, but it is very clear. Two plates are separated by distance D. The slab having the thickness T. Or we have to write down the first slab, EP into T. And what about this? It is very simple, D minus T. So I am writing here D minus T. Now it becomes a E0 means just writing in this way. And now we calculate the potential difference. Now the potential difference becomes potential difference is V equals to V0 minus Vp, as a E0 minus Vp, V0 minus Vp. Now substitute the values here. So V equals to, value of V0 is how much? E0 in bracket D minus minus EP into T. Now substitute the values. This value E0, value of E0 Q divided by A epsilon 0, Q divided by A epsilon 0 in bracket D minus T. Value of EP is how much? EP equals to QP divided by A epsilon 0 into T. This is my second value. But now we substitute here, this is my potential difference. But the potential difference, this is between the remaining sides, that is a D minus T. But here the potential difference between the capacitor is how much we calculate. This is a E0 in bracket D minus T minus of EP naught minus of net, that is the net electric intensity. So it becomes a plus. So E into T. So E into T is nothing but E0 upon T. E0 means Q upon A epsilon 0 into K upon the T. Now it is in the next part. So the V equals to Taking q upon a epsilon 0 as a common, q upon a epsilon 0 as a common, here in bracket becomes a d minus t minus t upon k. So d equals 2. Now again we want to solve this. Sorry, this is a plus sign. So there is a plus sign. Again dt get cancelled. Q upon a epsilon 0 d minus t plus t, it becomes a cancel. So here the term becomes d, not in this way, d minus a in bracket d minus t plus t upon k. So the next part here becomes v equals to q upon a epsilon 0. Now check the term, k in bracket d minus t plus t by k. This term comes here. Now we are substituting here this q in bracket. Always substitute directly, c equals to q by v. Just I am writing the same step, k in bracket d minus t. What is this only p by k, but c equals to what? Q by. So c becomes q as it is. Then v equals to q divided by a epsilon 0 in bracket d minus t plus t by k. So c becomes q get cancelled. Here q get cancelled. A epsilon 0 goes on the upper part. So it becomes a epsilon 0 divided by d minus t plus t by k. Or for your simplification, write down in this way. This is a capacitance of a parallel plate capacitor filled with a dielectric whose thickness is t. C equals to a epsilon 0 upon d minus t plus t by k. Okay. Now just pause this video. See where we are getting some confusion. I think if you have not understood this part, E0 minus Et equals to E0 by k, this part is not understood by you. Or this part, V equals to E0 in bracket d minus t plus E0 upon k. Here because we are writing the V equals to V0 minus Vp, there is a negative sign, so we are getting here the positive sign. Why we are added this? Why the net electric intensity added? So the net potential difference is added. Is there any query? Is there any difficulty or doubt? Then ask on my number. Okay, just pause the video, write down all the things.